first lecture of Section 2.4. We will discuss Section 2.3 when I get back next week. We're not going to omit it completely just from this discussion for this week. This is a rather short section. It involves two rules, the product rule and then on the next slide the quotient rule. So we're going to take a look at this product rule and just kind of identify some information about it. For instance, we've got two functions, f of x and g of x, and we're multiplying those together. Take a look at what happens with the f of x. I'll highlight it in yellow here. When you take the derivative of the product of two functions, notice that we are multiplying in the first term. We've got the product of two items, one being the first factor, and then the derivative of the second factor, plus, and then we use the derivative of the first factor and multiply it times the second factor, which is the second function. We then take a look at, let's look at g of x, and notice that we do in fact have g of x in both of these, but in the first one we're looking at the derivative of it, and in the second one we have just the function itself. So in both of these we have the product of both functions, but we use the function of one times the derivative of the other, and we switch then which one we have the derivative. Now this rule can be extended to more than two factors. We have here f of x, g of x, and h of x, and notice that in these I'll just highlight function f, that in the first term of the derivative, we take the derivative of f of x and then g of x, h of x, plus, and then we have the derivative, or this function f with the derivative of g of x and then h of x, and in the last one we have again f of x, but now we take it times g of x and the derivative of h of x. So in each of these products here we have a derivative of one of the three. Now we're not going to encounter this very frequently. This may not come up in too many of our much of our work, so we're going to primarily focus on this simplified form of that product rule. So let's look at the first factor, or the first problem here. Now we could, from section 2.2, we could multiply these together and take the derivative as we did back in section 2.2. Let's practice though our product rule. So we're going to look at the derivative of g of x, and the rule is that we take the first factor times the derivative with respect to the input variable of the second factor, plus, and then we take the second factor times the derivative with respect to the input variable of the first factor. Now if you're looking back at the first slide and you say, well, on the rule it said we take the derivative of the first factor times the second factor. Remember that in multiplication it is commutative, so it doesn't make any difference in which order we multiply them. Also we're adding, and addition is also commutative, so it doesn't matter if we, as I did, I start with the first factor and the derivative of the second factor plus the second factor times the derivative of the first. Remember, as I said in section 2, we need to show using the derivatives, and especially starting with this section, and it becomes extremely important, that the first step is to show the derivatives that we're going to be using. So as I have shown here, I am showing you the derivatives that we're going to use. Now the second step then is to actually take the derivatives, or derive the derivatives, or simplify, whatever term you want to use. So we have x minus 4, and then the derivative of x plus 2. Remember, we take the derivative of the first term, so we have the derivative with respect to the input variable of x. plus the derivative with respect to x of the second term, plus x plus 2, and I'm going to erase my little second step here because we're not really doing that yet, because at this point I also then must take the derivative of this. So the derivative with respect to x of x minus the derivative with respect to x of 4. So we're still showing the derivatives in that line and in this line. Okay, now let's look at this. My first factor is x minus 4. The derivative of x with respect to itself, remember what we do is we take the coefficient, which is 1, times the exponent, which is 1, and we multiply it then times x to the 1 minus 1 power, because we always subtract 1, plus, and we can look at the derivative for this, and this would be 2 times, and if you look at this, I'll just remind you that 2 is the same thing as 2 times x to the 0. X to the 0 is 1, so we could say we're multiplying 2 times 0 times x to the 0 minus 1. If you recall, back in section 2.2, the derivative of a constant, which is 2, is always going to be 0, and this is going to show that that in fact does happen. Okay, so we have that plus, and let me put another bracket in here to complete the work that we did here. So this is the derivative of x, and this is the derivative of 2, plus, and now we have our plus x plus 2, so we're using this, times, and we have again the derivative of x, so that's 1 times 1, x to the 1 minus 1, minus the derivative of 4, and again that'd be 4 to the x times x to the 0, so we have 4 times 0, x to the 0 minus 1. And so our second step, which we just did, was to actually take the derivatives. Okay, so the first step is to show the derivatives we're going to take. The second step is to actually take those derivatives. And the third step is to show at least 2 algebra steps. At least 2. Okay, so we have x minus 4, and then this is going to be x to the 1 minus 1 is 0, so this would be 1. This is going to be plus 0, which we really don't need to write, but we're going to show it just for now. Plus, here's our adding, x plus 2, and inside here we'd have 1, and this would be x to the 0, so this is just 1, minus, and again we'd have a 0 over here. So we end up with x minus 4 times 1 plus x plus 2 times 1, and I would expect you to simplify this to be 2x minus 2. So again, going down through the steps I expect you to show me. One is to show me the derivatives we're going to take. The second step is to actually take the derivatives, and the third one is to show at least 2 algebra steps. Now don't feel like you have to only take 2. You know, I expect you to carry them on into a reasonable finish such as this. Okay, so what we have then, let's go back. Are we finished? It says determine the derivative at the point 4, 0. Now, just to remind you, this is our derivative, 2x minus 2, and this is a function whose output is the slope of a line tangent to a curve at a point. Okay, so this yields us the way of finding those. We want to know what is this at a point, or at the point, for 0. So we have the derivative of 4, and this would be 2 times 4 minus 2. 2 times 4 is 8 minus 2 is 6. So the slope of the tangent line at the point for 0 on our curve, on our graph of x minus 4, the quantity, times x plus 2, would in fact be 6. Now I said that there was another way we could write this, so let me put that in green. The alternate way would be to take, let's see, g of x is, again, x minus 4 times x plus 2. Let's use FOIL. First terms, x squared. Outside terms, 2x. Inside terms, negative 4x, so that's negative 2x. And the last terms would be negative 8. Now, if we look at the derivative of that, we'd have the derivative with respect to x of x squared minus the derivative with respect to x of 2x minus the derivative with respect to x of 8. And our derivative of 2x would be 2 times the leading coefficient of x to the first power minus, and the derivative of 2 would be 2 times 1 with x raised to the 1 minus 1 power minus the derivative of 8, which would be 0. So our answer would be 2x minus 2. Does that compare? Yes, it does. That's a little faster because we are just having to expand the product of the binomials and then take each individual one. So this is an example of one where we can in fact use our product rule, which is what we used up here, but it would be a little bit easier to just use the expansion on that. Okay, if we look at this on a the graph rather, pick up a graph page, and we're going to multiply. So I'm going to insert the factors of x minus 4, and we're going to multiply with then the factor of x plus 2. And if we're looking at the point 4, we would then put a point on, and I'll just put the point there. I'm going to change the value of that, and then we'll draw a tangent to that at that point. And if we are looking then for the slope of that, we'll go in here to measurement, look at the slope of that line, and the slope of that line is 6. Does that compare with what we had? And the answer is yes. The slope of the tangent at the curve is equal to 6.